Voltage and current are the two quantities that describe any circuit, and they are quite different things. Voltage is the push, the energy given to each unit of charge. Current is the flow, how much charge moves past a point each second. In a solar cell, voltage comes from the built-in junction. Each silicon cell makes only about half a volt, which is why dozens of cells are joined inside a panel to build a useful voltage. Current is the rate of charge flow, measured in amperes. In a panel, the current rises and falls almost directly with the sunlight. Double the brightness, and you roughly double the current. Voltage behaves differently. It changes only a little with sunlight, but a lot with temperature. As a panel gets colder, its voltage rises, and that cold case sets the safe limit for a string. The two combine through how you wire panels. Series connection adds the voltages, parallel connection adds the currents. That is how a string is built to match what the inverter expects. Two ratings matter most on a datasheet: open circuit voltage, the highest voltage with nothing connected, and short circuit current, the highest current with the terminals joined. Both come from the standard test conditions. A safety reminder follows from this. A disconnected string still has its full open circuit voltage, and in cold weather that voltage is even higher than the label. Always measure before you trust it. So voltage is the push, current is the flow, sunlight drives the current, and temperature drives the voltage. Hold those four facts and string design starts to make sense.